Hey guys, it's Miss Maneely, and I'm going to go through the last lesson before our quarterly assessment, which is going to be on Thursday. We just have a couple quick things to go through that relate back to the unit circle and right triangles and the basic trig functions that you learned in geometry. We're going to just focus, though, on the sine, cosine, and tangent functions, and then after the quarterly, we'll talk about some of the others. I'm just going to cover the stuff that you need to know for the quarterly assessment. All right, so in your warm-up, you were given the top half of a unit circle, and there were some missing pieces to it, and so you are asked to fill in the missing pieces. Let's go ahead and look at the degree measures first and start talking about some patterns that you should see in these values. So for example, if I'm looking at the degrees and I start here, this would be my x-axis, that's going to be my standard position, and if I look at the first angle, I can see that it's 30 degrees. The next angle is 45, and then it's 60, and then it's 90. And if I take a look at the difference here, this is 30 degrees, this is a difference of 15, this is a difference of 15, and then this is a difference of 30. And those patterns continue all the way around the circle. So for example, this distance here is going to be 30, 15, 15, 30. So on your calculator, and actually, let me make this a little bit smaller so you can see my calculator. If you had to complete the unit circle on your own, for example, and at some point you will have to do that, we're not going to make you do it before the quarterly assessment. In fact, on the quarterly assessment, you'll have a copy of the unit circle, so don't sweat that right now. But we do want you to become very familiar with it because we're going to be using these angles constantly, and if you can have them memorized, it really does make life a lot easier. But when you're filling out the unit circle and you're filling out the degree measures, you start with 0 and then you add 30. Whoops. We have, well, obviously 0 plus 30 is 30. And then you add 15. And that gives you your 45-degree angle. And then you're going to add 15. And that's going to give you your 60-degree angle. The next thing you want to do is add 30. So it's always going to be 30, 15, 15, 30. 30, so I'm going to add 30. And that gives me my next angle. So my next angle should be at 120 degrees. Oops, I can't get my cursor to move. All right, and then if I add another 15, I'm going to be adding 15 to that, and that's going to give me the 135, another 15, that gives me 150, and then 30. So again, the pattern of your angles all the way around the circle is adding 30, 15, 15, 30. 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. And if you just do that, you can get all of the degree measures around the circle. So it's not really about memorizing the numbers, it's about understanding the patterns. And once you see the patterns, it's really easy to reconstruct the unit circle. If you take a look at the radian measures now, so now instead of looking at the degrees, we're going to be looking at the pies. So notice how in the first quadrant, remember this is our quadrant 1, and this is quadrant 2. We start with pi over 6, and then we go to pi over 4. The next one is going to be pi over 2, sorry, pi over 3, and then pi over 2 cuts that half of the circle in half again. And so notice that the numbers are going down, 6, 4, 3, 2. There is no pi over 5. So it goes 6, 4, 3, 2. And then notice those denominators go back up. 3, 4, 6, and then we have our whole pi. Oops, I forgot about the 180, sorry. And so we go from 0 pi to pi over 6, pi over 4, pi over 3, pi over 2, and then the denominators increase again. 3 over 4 over 6, and then it's a whole number. If I were to look at the radian measures down here in this quadrant, okay, this is going to be another one, because I'm going to go in order. It's going to be pi over 6. This is going to be over 4. Whoops. And this is going to be pi over 3. Now my numerators, there is a pattern that I have to remember. And then again, this is going to be a pi over 3. This is going to be a pi over 4, and this is going to be a pi over 6. So your pi over 6s are always going to be closest to your x-axis, and your pi over 3s are always going to be closest to your y-axis. When it comes to the numerators, if you take a look at the first quadrant, the numerators are all 1 pi. If you take a look at the second quadrant, notice that all of your numerators, if you take a look, we've got 2 over 3, 3 over 4, and 5 over 6. All of your numerators are 1 less than the denominator. In the next quadrant, it's going to be 1 more. So this is going to be 7 pi over 6. This is going to be 5 pi over 4. And this is going to be 4 pi over 3. This is going to be 3 pi over 2. Okay, so that's the pattern in the third quadrant. And again, it's not about memorizing all these numbers. There's, I think, 65 numbers on the unit circle. You don't need to memorize all 65 numbers. There's really only 5 different numbers and then a bunch of patterns. So if you can remember the patterns, it's really easy to reconstruct this. The fourth quadrant is the only one that's a little bit tricky. So let me just make sure we label this. This is the third quadrant. This is the fourth quadrant. So in the fourth quadrant, we double the denominator and subtract 1. So for example, if I'm looking at this measure right here, if I double 3, I get 6. Well, this is 5 pi over 3. If I double the 4, I get 8. This is going to be 7 pi over 4. If I double the 6, I get 12. This is 11 pi over 6. So that's the only one that's a little bit tricky. And like I said, on the quarterly assessment, you'll be given a completed unit circle. So I'm not asking you to memorize them right now. But at some point, you will need to be able to reconstruct the unit circle. The last thing we want to make sure that we can do is identify the ordered pairs that are associated with each of the numbers or each of the angles. So the ones that are obvious are going to be obviously the ones on the axes themselves. So like at 0 degrees, we know that that's going to correspond to 1, 0. Anything that's pi over 4 is your 45-degree angles, and those are always going to be your square root of 2 over 2. And square root of 2 over 2 always goes along with square root of 2 over 2. So you're always going to put the square roots of 2 over 2 together. The other pairs, the 1/2 and the square root of 3 over 2, always go together as well. So you just want to remember that if it's got a 6 in the denominator, the square root of 3 over 2 comes first. If it's got a 3 in the denominator, the 1/2 comes first. And then you just got to remember the sign of x and y in each of the quadrants. So for example, in the first quadrant, it's positive, positive. In the second quadrant, my x's are negative, but my y's are positive. In the third quadrant, everything's negative. And in the fourth quadrant, my x's are positive, but my y's are negative. And so if I think about the ordered pair here, where I'm looking at 5 pi over 6, since it's got a 6 in the denominator, I know I'm dealing with the ordered pair where it's the square root of 3 over 2 and 1/2. But since I'm in the second quadrant, the x value has to be negative. So it's going to be a negative square root of 3 over 2. If I were to jump down here to this ordered pair that's also associated with 7 pi over 6, I know that it's going to be the square root of 2 over 2 and 1/2. Oops, I'm sorry, the square root of 3 over 2 and 1/2. But I know they both have to be negative since it's in the third quadrant. If I were to jump over here to 11 pi over 6, again, it's got a 6 in the denominator. It's going to be the square root of 2 over 2 and 1/2, except this time, since I'm in the fourth quadrant, the y value has to be negative. Okay, I'm not going to spend any more time on this right now since, again, you'll be allowed to use the unit circle on the quarterly assessment, but we will continue looking at these patterns over the next few weeks. The next set of problems requires you to use what you know about the Pythagorean theorem to find the missing side. So for example, in letter A, you're given the lengths of the legs of a right triangle, and you're asked to find the hypotenuse. Well, if we use the Pythagorean theorem, that basically is telling me that 4 squared plus 3 squared is equal to x squared. And if you don't know your if you don't know your powers, then obviously you can use your calculator, but there will be a non-calculator section on the quarterly assessment. I will say that most of the items on the non-calculator section are actually pretty easy. You don't really need the calculator, and even some of the items on the calculator section can be done without a calculator. So it's not really driven by the calculator, so don't sweat it. So 4 squared is the same as 4 times 4, that's 16. 3 squared is 3 times 3, which is 9. And that's going to equal x squared. And 16 plus 9 is 25. And then to solve for x, we need to take the square root of both sides. Now technically, when we do this, we should have 2 answers, a positive 5 and a negative 5. But because x represents the length of a triangle, it's got to be positive. In letter B, notice this time we have the value of the hypotenuse, but we're missing the length of one of the sides. So I've got to make sure that I set up my equation correctly. This is basically telling me that 12 squared plus x squared is equal to 13 squared. Okay? These are perfect squares that you will need to know on the test. So 12 squared, this is something you're going to have to remember. 12 squared is 144. Obviously, we don't know what x is yet. And 13 squared is 169. So those are two perfect squares that you need to remember. So maybe put a little star next to letter B to remind yourself to remember these, because this is a problem that you will not be able to use a calculator on. So if I want to solve for x squared, I'm going to need to subtract 144 from both sides. And again, if you can't use a calculator, you're going to have to actually do the subtraction. So 9 minus 4 gives me 5, and then 6 minus 4 gives me 2. And so I get x squared equals 25 again when I take the square root of both sides. And we get x equals 5. So this is another perfect right triangle where all of the sides are whole numbers. Okay, we're going to see some problems involving some radicals, some square root problems today in class. But on the quarterly assessment, you're not going to have a lot to do with answers that are left in radical form. Most of your answers will be whole numbers. Okay. If you want to pause the video now and go ahead and take a look at the homework from last class, you can do that. And then when you're done, go ahead and press play. Okay, so today's lesson is all about evaluating trig functions, and we're going to do it several different ways. You've already done this using right triangles in geometry. We're also going to evaluate the trig functions using the unit circle as well, and I'm also going to show you how you can do this on the calculator. For this lesson, though, I don't think we're really going to need a calculator for the beginning. You do need a calculator for everything else, but for this first part, I'm going to blow this up a little bit so you can see it a little better. So if you guys remember from geometry, you learned about Sohcahtoa. And Sohcahtoa refers to the relationship between the sides of a right triangle and the angle measure. So if I'm referring to this angle here, theta, and I want to relate the sides of the angles to the different trig functions, if you remember Sohcahtoa, the S in Sohcahtoa is referring to the sine function, the C is the cosine function, T corresponds to tangent, and then the O and the H and the A refer to the three sides of the triangle. So A is your adjacent side. It's always going to be the side that is next to theta. That is not your hypotenuse. The opposite side is always going to be the side that is opposite theta, and your hypotenuse is always going to be the side that is opposite the right angle. And so it's important that you recognize which side is which, because it does matter and it will change your answers if you're incorrect. So the sine of theta, if you think about Sohcahtoa, is referring to the opposite over the hypotenuse. So it means that it's going to be the opposite side over the hypotenuse. Okay. If you're dealing with the cosine, we'll think about ca, the C-A-H, is referring to the adjacent side over the hypotenuse. And then the tangent is going to be the opposite over the adjacent side. Okay? So let's take a look at an example. You're told that the cosine of theta is equal to 3/5. The easiest thing to do here is to go back to your relationship for the cosine. We know that the cosine is equal to the adjacent side over the hypotenuse. So if you're given a fraction, you can simply label the numerator as your adjacent side and the denominator as your hypotenuse. I don't think I drew a picture of a triangle on your paper. So why don't you go ahead and draw a triangle, and then let's label the sides that we know. So here's my angle theta, and we've just labeled the adjacent side to be 3. So the adjacent side means that it's the side next to theta. That's going to be this base right here. So that means that this has a length of 3. The denominator is 5. That gives me the length of my hypotenuse. So if I want to figure out anything else, I've got to figure out what this missing side is. And some of you guys may recognize that this is, again, another perfect triple or a perfect triangle. But if you don't, then in order to calculate it, we're going to do what we did on the warm-up. Just remember that 5 is your hypotenuse, so you have to set up the equation properly. We'll have 3 squared plus x squared is equal to 5 squared. And 3 squared is 9. So we've got 9 plus x squared is equal to 5 squared, which is 25. If I subtract 9 from both sides, we get that x squared is equal to 16. So when I take the square root of both sides, I get that x equals 4. Could be negative 4 too, but in this case, since I'm dealing with the length of a triangle, whoops, I want to make sure that I keep it positive. For now, anyway. I'll show you what happens when we start flipping this thing around the unit circle. So the next thing in part B, it says, if theta lies in quadrant 1, what is the value of the sine of theta? So I know that this part of the question sort of throws you off. So let's focus on what the sine of theta is. The sine, remember, if we go back up here, is going to be the opposite over the hypotenuse. So if I think about the opposite over the hypotenuse, that's going to be 4 over 5. So what's this business about having theta lying in quadrant 1 or theta lying in quadrant 2? That's important for us to know as well, because it turns out that the sine of theta could be a positive 4/5 or a negative 4/5, depending on where it is in the unit circle. So let me just draw a quick set of axes for you. We said that in quadrant 1, the x and the y values are positive. In quadrant number 2, the x value is negative, but the y value is positive. In quadrant number 3, they're both negative. And in quadrant number 4, x is positive and y is negative. What we need to do is relate x and y to the sine and the cosine. And we're actually going to do that in the next section. So let's hold off on finishing up B and C and jump to the next question. Because now what we want to do is relate the sine and the cosine and the tangent to the values on a unit circle. So what I've put on your paper is an image that we had from last class, where we have our unit circle, and remember we call it a unit circle because it has a radius of 1. And we said that all of the points on the unit circle are going to be of the form x, y, where x, basically, if I were to draw a triangle within my, or like if I drop an altitude from my radius, let me explain it that way, then the x value corresponds to the base of the resulting triangle, and y represents the altitude. Okay, well, let's think about what we know about our relationship between cosine and sine and the sides of a triangle. So remember, if this is where my theta is, the x value now is describing my adjacent side. And the y value is now describing my opposite side. And 1 corresponds to my hypotenuse. So let's think about Sohcahtoa. Again, okay, so the first one, I switched the order. So we're going to start with cosine this time. We said that cosine is equal to the adjacent over the hypotenuse. Well, now let's use the values from our unit circle. So if I think about the side that is adjacent to theta, that's x. And my hypotenuse is 1. So if I think of this, x over 1, if we reduce that fraction, just becomes x. So it turns out that the cosine, when I'm dealing with a unit circle, is just referring to the x value. Let's look at sine. Sine refers to the opposite over the hypotenuse. Well, let's look at the opposite side. The opposite side relates the y value of that point. And the hypotenuse, again, is 1. So sine corresponds to y over 1, which just reduces to y. So that means that the sine corresponds to the y-coordinate of the values on the unit circle. Tangent is your opposite over adjacent. And again, we said the opposite side is y, and the adjacent side is x. So the tangent is going to be equivalent to y over x. Since sine is equivalent to y and x is equivalent to cosine, I could also think of tangent as the sine of theta over the cosine of theta. And hopefully this is stuff that you remember from geometry. So if we go back up to the previous slide, when we were thinking about values being positive and negative, we can refer to x and y, but basically, actually let me do this over here, all of my ordered pairs x and y are equivalent to the ordered pair cosine of theta, sine of theta. And that's going to be important that we can relate these values to one another. So if I want to find the sine of pi over 2, I can just look at the ordered pair that's associated with pi over 2 and pick the y value. Makes it really easy, and then you don't need to rely on your calculator. So let's go back to that first example. Okay, so we said in quadrant 1 it's positive, positive. That means that the cosine is positive and so is the sine. Both are positive. So is x and y. If we look at the second quadrant, that tells us that our cosine is negative, but our sine is positive. And in quadrant 3, our cosine and our sine are both negative. In quadrant 4, our cosine is positive and our sine is negative. So one way that you can remember this, and this is going to be kind of funny, you might want to write this actually if you have your unit circle paper. I think you'll see around the 4 corners, it'll say stuff about positive and negative. So in quadrant 1, all of your functions are positive. Okay, so I'm going to underline that A. In quadrant 2, it's the sine functions that are positive. Well, let me say sine is positive instead of r. All of the others are negative. If you look at quadrant 3, it's the cosine that is positive. All others will be negative. So the sine and the tangent in quadrant 3. I lied. Ignore what I just said about quadrant 3. It's going to be the tangent because the sine over the cosine, the tangent is positive in quadrant 3. I was getting ahead of myself. And then in quadrant 4, it's the cosine that's positive. And there's an easy way to remember this. So we said that all of the functions are positive in quadrant 1. The sine is positive in quadrant 2. The tangent is positive in quadrant 3. And the cosine is positive in quadrant 4. And one of the things that I learned in school was that the way that you can remember the order is that all students take calculus. You'll remember that, right? Because you're all planning to take calculus. So I don't know how relevant that is to everybody, but one of the things that I learned when I was teaching at a different school that students did tend to remember, and this is a hush-hush, that all, I'm going to whisper it, strippers take cash. They also take coins and checks and credit as well. But if you can remember that order, it'll help you remember which functions are positive and which ones are negative. So if we go back to these 2 questions here. Oops, I don't know why it drew a straight line there. So if we're talking about the sine of theta based on knowing that the cosine of theta is 3/5, I know that the number part is going to be 4/5 no matter where I am. In quadrant 1 is where everything is positive, including the sine. So for my answer in part B, I know the sine would have to be a positive 4/5. But if theta were an angle actually it would be going this way, in quadrant 4, then the value of my sine must be negative. And so I have to remember to put a negative there with my 4/5. And there is a problem like that on your quarterly assessment. There's one more practice problem in today's lesson, and then there's some practice on your review guide. But because I want to make sure that you guys have some time to work on the review in class, I'm going to move on. Okay, so when you're asked to evaluate a function and you're given like the cosine is equal to a fraction or the sine is equal to a fraction, think about the relationship between the sides. Think about Sohcahtoa, construct a triangle, use the Pythagorean theorem to find the missing side, and then get your relationship that you need and then figure out the sign based on our strippers. All right. Another way to evaluate a function is thinking about the coordinates on a unit circle. So for example, if I think about my angle measure of theta equals pi over 6. Remember we said that if it has a 6 in the bottom, and let's see if you guys can remember this. If it's got a 6 in the bottom, that means that we're dealing with the square root of 3 over 2 and 1/2. And because the 6 is on the bottom, that means that the square root of 3 over 2 is going to come first. And if you don't believe me, we can check our unit circle and look for pi over 6. So like I said, if you can remember some of these relationships, it saves you a whole lot of time from like digging in your backpack and trying to find your unit circle and then answering it from there. But once you know this relationship, if I need to find the cosine, well, we just said that the cosine is equivalent to the x value. Well, which of these two numbers corresponds to x? It's the square root of 3 over 2. The sine is going to correspond to your y value, which is just 1/2. A tangent is a little tricky because you do have to remember how to divide fractions. Remember we said that the tangent is going to be y over x. My y value is 1/2. My x value is the square root of 3 over 2. And this is going to bring you back down to like 4th or 5th grade, where dividing fractions is the same as multiplying by the reciprocal. You're not going to have to do this on the quarterly assessment, but it is something that you're going to see in practice, so I do want to discuss this. Since we're dividing 1/2 by the square root of 3 over 2, remember dividing fractions is multiplying by the reciprocal. So I'm essentially going to multiply and flip that bottom fraction so it's 2 over the square root of 3. When I multiply, these 2's are going to cancel, and I'm going to be left with 1 over the square root of 3. And for now, I'm going to let you leave your answer just like that. So the tangent of theta would be 1 over the square root of 3. Let's take a look at another example. This time we're looking at theta equals a negative pi over 4. So if we think about our unit circle, remember pi over 4 is right here. It's a 45-degree angle. Okay, because remember, this whole quantity is pi. My 90-degree angle is going to be pi over 2. So pi over 4 is my 45-degree angle. If it's 45-degree angles, that's going to correspond to the square root of 2 over 2 and the square root of 2 over 2. But this angle is a negative pi over 4. So that means I'm not going up, I have to go back. And so that leaves me at this point on the unit circle. Since I'm in quadrant 4, this is where you want to remember the x value is going to stay positive, but your y value is negative. Now obviously, like I said, you're going to have the unit circle available to you, so you can just look at your unit circle. You don't have to have this memorized yet, but it is really helpful if you can remember these patterns. So this is the ordered pair that I'm going to use to evaluate my functions. The square root of 2 over 2, negative square root of 2 over 2. Remember the cosine is just my x. And in this case, my x is the square root of 2 over 2. This one's going to be pretty easy. The sine is my y value, and the y value of this ordered pair is a negative square root of 2 over 2. The tangent, again, is going to be y over x. So we're looking at negative square root of 2 over 2 divided by a positive square root of 2 over 2. Or if we multiply by the reciprocal, the top fraction stays the same, and I multiply by the flip of the bottom one. So I'm going to flip the bottom one so it's 2 over the square root of 2. And both my 2's and my square root of 2's cancel, and I'm just left with negative 1. They don't cancel to 0. And if you think about this fraction, even though it's a fraction over a fraction, I'm dividing a number by itself. So it should end up being 1. And so that actually isn't as bad as the other one. So my tangent of negative pi over 4 is going to be negative 1. So on the test, you might see it looking like this, the tangent of negative pi over 4. And you're going to be asked to evaluate it. Or in this one, you might be asked, what is the sine of negative pi over 4? And so you'll locate negative pi over 4 on the unit circle and then tell me the y value. Okay, and then the last example I want to show you is how you can evaluate functions using your calculator. I don't know that there are many problems on the test that will allow you to use your calculator, but it is helpful during the times when you are allowed to use your calculator. The one thing you have to pay close attention, though, is whether or not you're dealing with radians or degrees, because you have to change the mode on your calculator. And that is something you have to be very, very careful of, is to make sure that you change it back and forth properly, because especially once we start graphing, you want to make sure you're using the proper mode. Now, you guys probably haven't done much of the using the mode window, but if you hit the mode button, this is how all of your calculators should be set, where we're in the normal mode. Your decimals are set to floating, and notice the third line, you can switch between radians and degrees. The other functions, the other options are more for like in pre-calculus. You can see in the second to last line, you can change from real numbers to imaginary, and you can actually perform operations using imaginary numbers on the calculator. Some of you may have figured that out. But what I want to do is make sure I'm in the correct mode when I'm evaluating these functions. So if I want to start with the degrees first, let's circle all the problems that involve degrees. So that would be number 1, number 4, and then this last one, number 6. And so if I want to do those first, I'm going to scoot down to where that line is, highlight degree, and press enter. And now my calculator is in degree mode. If you hit second and quit, now you can evaluate these 3 functions. And notice they're right above like your comma and your parentheses. So if I want to figure out the sine of 15 degrees, I'm literally just going to type in the sine and 15. You don't have to worry about hitting a degree button because it's already been pushed. And then you can round. I usually round to 3 decimal places. So this would be 0.259. And these values you can try, but a lot of times you're not going to be able to get them back into a fraction because they're irrational. So let's go ahead, and why don't you try and go ahead and evaluate the other 2 degree values. If you want to press pause. Okay, so the answer for the next one, for the sine of negative 150, it's going to be negative 1/2, negative 0.5. Now that obviously is something that you can change back to a fraction, but you don't need to. Your tangent button, the tangent of 630, and this is going to be a little confusing, but notice that you get an error message. If you think about what 630 degrees is, that's too big, right? So normally we would go ahead and subtract 360. So if we have, if we go ahead and do our 630, I keep hitting the wrong button. We get 270 degrees. And if you think on the unit circle where that angle is, it's this angle right down here. And the ordered pair associated with that point is 0, -1. So if you try to evaluate the tangent, remember this is x, this is y. The tangent is y over x. So we're looking at -1 divided by 0. If you try to divide anything by 0, you're going to get an error message. And this is where you just want to say that the function is undefined. And most of the time you'll get the error message, and that's why, because the function is undefined. The next thing we can do are the radian measures, but in order to do them we have to go back to our mode. And so if we change our mode back to radians, go back to our home screen, if I want to evaluate the cosine of 2 pi over 3, I'm going to find my cosine, and then I'm going to hit 2, and please do not type in 3.14. You have a pi function on the calculator. If you hit the second button and then that caret, that'll type in the pi for you, and it'll give you the exact value of pi. Well, rounded to God knows how many decimal places we've gotten it to. Okay, and so if we look at the cosine of 2 pi over 3, we have -0.5 or -1/2. If we want to do the tangent of negative pi over 4, we've got the tangent, negative pi divided by 4. and you get -1. All of your tangents for anything with a pi over 4 are going to be either 1 or -1 because they're 45-degree angles and your x and y values are the same. Remember the square root of 2 over 2 and the square root of 2 over 2, when you divide them by each other, you're just going to have 1. So tangent is either going to be +1 or -1. And remember, our all strippers take cash. Our tangent is going to be positive in these two quadrants because everything is positive in quadrant 1 and only tangent is positive in quadrant 2. So if it's in any other quadrant, our tangent value would be negative. And negative pi over 4 is down here in quadrant 4. And then the cosine of pi, you actually don't need your calculator for this. If you remember, pi is that point right there. And so if you think about the ordered pair, it's -1, 0, so the cosine should be -1. But if you want to do this on the calculator, we're looking at the cosine of pi, and you get -1. And then I think the rest is just some practice. Okay, so there are 10 practice problems. Depending on how much time is left, you can either do a couple of these or begin your quarterly assessment review. I will post a video for the quarterly assessment review. Obviously, we're not going to be able to spend a lot of time in class talking about it because when you come in on Thursday, we are going to start the test right away so that there's plenty of time. Okay, I hope this was helpful. Please come into Bulldog Block if you have any questions.